And we're going to do about 4 problems today, and we're going to pick up with this spot, example 3, where it says write an equation for a line tangent. If you notice, we keep coming back to this. It's one of the common questions that's asked on an AP exam. You are going to have a question on the AP exam that involves what we call implicit differentiation. Does somebody remember why this is implicit and not explicit? Very good, because there's no like y equals, right? It's not solved for the y variable. So when we do that, we want to first identify the point, and we're given the point, aren't we? What if you were not given -7, -24? What if you're just given -7? Then what would you do? You would plug it in. Now, the reason why they've given you -7, -24 is it just so happens that -7, +24 is also a point on there. So this is not a function, is it? This is a circle with a radius of 25. Very good. So as you can see, there are 2 different y values for this given x value. That makes it not a function, so they have to give you that. Yes?
Well, where did you get the positive 24? Like that point?
So I'm just saying that if you plug this in, it would satisfy the equation, and if you plug that in, it would satisfy the equation. So they don't just give you -7 because it's like, are we referring to the positive 24 or the -24? So here we have it. We have the point. We need the slope. How do we determine slope? When in doubt, derive it. So let's take the derivative. What is the derivative of x squared? 2x. What is the derivative of y squared? Can somebody please explain to Jack how we do that? Yep. Anytime you take the derivative of something that has y, you simply attach a. That's it. And that's equal to the derivative of 625 is? 0. Okay, all right. So we're 0 for 2 so far. Okay, I've given you 2 types of things that are going to be on your test. And so far when I've graded them, we've had about a third of the people not do as told. We'll see if we can do this one. When you encounter this problem on the test, what do you think sometimes people put over here instead of 0? They put 625. Stop it. Okay? We all, I mean, we get why, right? But at the end of the day, it's a constant. Derivative constant is... Okay, please don't write 625. All right, so now we're going to solve for y prime. So I've got, I subtract my 2x, and I've got 2y, y prime is equal to -2x. Divide by 2y, and y prime is equal to? Let's cross off those 2's, right? We'll go -x over y. So what it tells me is that this will determine my slope so long as I know the x and the y value. What is the x value? So therefore the slope would be +7 over 24, and it is negative. Agreed? Okay? So I've got a -7 over 24. I want to write the equation for the line tangent. I'm going to erase this. Just give myself a little bit more space. Y minus or plus? Plus 24 is equal to -7 over 24 times x plus 7. So I've got y plus 24 is equal to -7 over 24 times x. And then -7 times +7, that will give me -49 over 24. And now I need to move this 24 over, right? So it's 24 over 1. I'm going to need it to have a denominator of. So I should multiply top and bottom by. So that would be 576 over 24. So if I take 24 over 1, I want to have a common denominator 24. I'll multiply top and bottom by 24. And 24 times 24 is 576. Better? So I get y is equal to -7 over 24 times x. And if I take -49 minus 576, -625 over 24. Sorry about that subtraction sign up there. I'll write it down here. 625 over 24. That is the equation for the line tangent. You can expect a question like that on the test. We all good? Okay, what's different about the next one?
The 4xy.
Yeah, we got this 4xy. What does 4xy say to you, Miss Ella? Very good. That's great, because based off of our previous tests and even previous years, this is something I don't know how to make people see, but yes, this is a product rule where we have f and we have g. So let's go ahead and go through that. The derivative of x squared, 2x plus, now I have to do the derivative 4xy. So 4 times y plus the derivative of 4x we leave alone, and what's the derivative of y? Y prime. Minus Jack Ladley, the derivative of 2y squared is 4y, and we attach a y prime anytime you take the derivative of a y. Got it? Does that start to sink in a little bit? Yeah. Equals the derivative of 3 is? 0. So now let's help our friends who weren't here yesterday. What do we do at this point? Because we have y primes in 2 locations.
We move the y prime to one side and everything else.
Good. All the y primes go to one side. Everything that doesn't have a y prime sits on the other side. So I'm going to have a 2x plus 4y. And on the other side, I'm going to have 4y y prime and a negative 4x y prime. Are we okay with that? So at this point, only take out the y prime. We'll deal with the 4 later on. So how do I isolate the y prime? I factor it out. So 2x plus 4y is equal to y prime times 4y minus 4x. Now what? So I have 2x plus 4y over 4y minus 4x is equal to y prime. You could take a 2 out of the top and the bottom. Everything's divisible by 2, agreed? So I could write this as x plus 2y over 2y minus 2x. So I have my point, which is 1, 1. I need to come up with the slope. How are we going to come up with the slope? Plug what in? Plug in the 1s. Yes. This 2? So look at what happens when I plug in 1. In the top, I get 1 plus, which is, in the bottom, you get 2 minus 2, which is, what does it mean if you're dividing by 0? It is undefined. What kind of slope is undefined? A vertical line. A vertical line has an equation of x equals or y equals? X equals. So the equation for this line is x equals, and what's the x value passes through? 1. Because you plugged in 1, 1, you came up with 0 in the denominator, that means that the slope is undefined. So the tangent line will be a vertical line, and in this situation, you can see a vertical line has the equation of x equals, and is x equals 1. Question, sir?
So did you divide the one side by 2?
Yep, divided top and bottom by 2. Well, I factored out the top and factored out the bottom, and they canceled. See that? Okay. Last example, somewhere where you have space, I want to do one more, okay? So anywhere where you can find space, there's just one more problem to hopefully help you as you're working on your stuff tonight. Anywhere you want, okay? You can turn to the front, you can turn wherever you want. Might have space right on the front. I want to do sine of y plus 1 is equal to x squared plus 3. Okay? Sine of y plus 1 is equal to x squared plus 3. I would like to find that derivative. Would you agree that this looks a little bit different than some of the other ones we've done so far? Yeah. So you're going to have a couple problems where you have to set up the chain rule, and this is a chain rule type problem. So what goes on the outside? Sine of u. What goes on the inside? y plus 1. What is the derivative of sine of u? Cosine of u. And what is the derivative of y plus 1? Y prime. See how people might be tempted to just write 1? But it is the derivative of y, so we write y prime. Now when we multiply these together, we get a y prime times the cosine of y plus 1. Is everybody okay with that being the derivative of sine of y plus 1? So then what is the derivative of x squared? And what is the derivative of 3? 0. Okay, so we have that as our derivative. We need to solve for what? Y prime. And as I solve for y prime, I'm going to divide by cosine of y plus 1. So y prime is equal to, you have two options for how you're going to write your answer. You could write it as 2x over the cosine of y plus 1. Does anybody else know another way to write your answer? Yeah, very good. 2x times the secant of y plus 1, because 1 over cosine is the same as secant. And so if you see something expressed in an answer key where you're like, well, where did that come from? Remember your reciprocal relationships that may exist in those situations. I would accept either one on the test. Here's what I've seen on the AP exam. Sometimes they express it like this, sometimes they express it like that, and since it's multiple choice, you have to know are they equivalent or not. Do you know what I'm saying?
Yeah, so would it matter? Like,
What I'm saying is on the AP exam, you might come up with this, but they might give this as a multiple choice option. So you're not even going to see this listed as an option.
what if they, could they get both?
No, they would give you one. Okay? All right, you guys are ready to finish off that assignment. Tomorrow we move on to higher derivatives. Please try to make sure you give this first assignment a good go.